Okay, welcome everyone. This is the week 2 webinar of the online elementary statistics class. And let me tell you the plan today. As always, I'll answer any questions you might have at the beginning or throughout. And then we're going to move on to probability. So that's chapter 3 in the textbook. And this week we only do one chapter. But that does not mean it's an easy week. A lot of people have a rough time with probability, so make sure you give yourself enough time to make it happen. So we'll define probability. I'll do some examples of probability, and then we'll even say, am I going to win the lottery? We'll find out what's the probability of winning. Then we'll look at some special cases of probability when you have and statements, when you have or statements, when you have given statements. Then we'll get into what does it mean for two events to be mutually exclusive. And then we'll talk about what does it mean for two events to be independent. And then finally, after that, we'll talk about project one. At this point, hopefully you have partners to work with. And tonight is the night that we'll go over what is expected for project one. So then you can now, after tonight, you'll be able to start thinking about your ideas on what your project should be about and what is your plan for your project. So that's kind of the next step. First step is get partners. Second step is get a plan. I do want to mention a few things. One is I graded, believe it or not, I think I spent like almost every hour of the day, and I woke up really early this morning, except for a little bit of teaching of grading your assignments. So I have graded them, and you can look, you can see my comments, and I put in a lot of comments, so make sure you do, because that'll help you get some ideas. I want to make some suggestions on things that a lot of people didn't do right, and you should in the future. One is the discussion post, original post, first post is never due on Sunday, it's due on Thursday. So if you post it later than Thursday, then you lose points. So don't do that. Okay, on Canvas we'll say Sunday, but then it'll also say it's due on Thursday. So it is due on Thursday for the original post. Sunday is when the final reply is due. So that's kind of how the due dates work. The other thing is, if you post it by Wednesday, I'll take a look at it and give suggestions for your original post. By the way, not your reply, but for your original post. If you post by Wednesday, I give you a little extra help, and I'll take a look at it. And if there's any issues, I'll let you know of them so you can fix them. So make sure you read my comments. And I always post a kind of a model post and a model reply. So make sure you look at that, and that'll help you look at what posts might look like in terms of the discussion post assignments. So hopefully that makes sense to all of you. And if you have questions, you can ask, and you can also get help from the tutors. Definitely will be helpful. And I'm just looking to see. I don't think we have, let me see. No, don't think so. I also added something to the syllabus, which I thought was pretty cool. And so let's go to the syllabus. If I go syllabus, I put chat box in. So there's a chat box to answer questions you have about the syllabus. And there's also a chat box to answer questions you have about statistics in the textbook. So if you click on this chat box link, okay, AI is good for learning. Don't use AI for writing your posts. I can tell, and I'm very fierce on grading when you do that. It's really hard to get full credit when you make that mistake. So if you want to say, hey, what question might you have about the syllabus or about the class? Things like maybe can I wait until Sunday to post my first discussion post. And it'll let you know. And it tells you no. Says that it should be made by Thursday. So it'll actually answer your questions. AI is pretty amazing what it can do. So I created this. I'm actually taking a course on using AI for learning. And this was one of the assignments. So I figured I could give it to you guys and let you have it. So there's all kinds of things that AI is pretty good about, helping you. It's not good about doing your assignments because again, I will not be nice to you. And I can tell just by looking whether AI did it or not. Any questions? Any questions on the new piece of the syllabus? Okay, if there are no questions, then what I want to do is I want to go to the definition of probability. I'm sure you've all heard the word probability before, but let's talk about what it's all about and let's do some like very easy examples. Okay, so let's suppose I got one here. I got a coin. Okay, hopefully you can all see that. And I flip the coin. What is the probability that the coin lands on heads? I bet you all should be able to know that because that's a really easy one. Okay, so the first thing, it's always best to write it as a fraction or a decimal. So yeah, 1/2 is the way we want to write this. So let me write down what it is and explain why. Okay, again, this is an easy one and we're going to do much harder examples too. But I want to start easy so you can get the idea of what's up. So let me make an equation out of it. And I can do fraction. So that one, I believe. Yep. So that's going to be 1/2. And the reason for that is that if you look at a coin, there are two sides of a coin. Hopefully you all know that. So there are two different things that could happen, heads and tails. Okay. And that's the denominator. The denominator is how many different things are possible. Okay. And we're assuming that all things are equally likely. And then the numerator is how many make it happen. So there are two possible things that could happen. The it is heads, and there's one that will make it happen. Any questions on that really easy example? Okay, so the next one is, let's suppose, let's suppose I take a deck of cards and I mix them and I pick a card at random. What is the probability that this card is a spade? Anyone know how to do that? So I'll give you a hint. The first thing you want to do is make a fraction. So I'm going to insert equation, make a fraction out of it. And we're going to say, how many different things could happen? How many cards are there in the deck? Some of you may or may not know it. It's not a tricky deck, by the way. Yeah, it's 52 cards in the deck. So 52 is the denominator. And then how many of those cards are spades? And if you don't know cards well, let me read them out. There's the ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. And if you count those, there are 13 of those cards will be spades. Okay. You can write that as 1/4. There's different ways of writing it. One is 1/4. The only problem with that is it doesn't tell the story as well, that there's 52 cards and 13 are spades. Okay. You can also write it as a decimal, which is 0.25. And that is kind of sometimes that's what you'll do on the assignments. So always read the instructions for the assignments to if it says what you're supposed to do, make sure you do it. If it says, round to 4 decimals, make sure you do that. Any questions on that example? Nice and easy one, right? They're going to get much harder, by the way, but we're starting with the easiest ones. Not too bad, right? Okay, so let me give you the definition of probability in general, which I pretty much already said, but now I'm going to give it to you in writing, and that is the probability of an event A occurring is the number of ways that A can occur divided by the total number of things that can occur. And that is given that every item is equally likely. So the way you write it, the symbols is use capital P for probability, parenthesis, A, close the parenthesis. That means probability of A. Then you write equals, you make a fraction, and then you count the number in A and divide by the number in the entire set. Any questions on that? Okay, you ready for a harder one? All right. What if I pick, now I'm going to change things a bit. I'm going to pick a card. Okay. And then I'm going to pick another card. So I pick the first card, look at it. Pick a second card, look at it. Okay. What's the probability they're both kings? So that one's going to be a bit more difficult. Okay. Because counting takes a long time. That's the last thing you want to do. It's just not fun at all. Okay. Yeah. So my warning was it's difficult. If you didn't find it difficult, you didn't do it right. Just let you know, it's not a simple fraction. So let me tell you the way to do it. So what you do is you say, we're going to do this one card at a time. What's the probability this first card is a king? What's the probability the first card is king? Yeah, 4 out of 52. So I'm going to call that K1 for first king because there's 2 cards. There's K, so 1 and 2. I'm just going to call them that way. And let us pop in 4 divided by 52. Okay. We want the probability that both are kings. We don't have that. We just have one. Okay, so now what we're going to do is we're going to say if the only way to get 2 kings is for the first to be a king and the second to be a king. So here, if the first is a king, what's the probability the second is a king? Yeah, so now we're going to do something similar, but you got to think about it instead of just, write 4 out of 52 again, because it's not. So I'm going to make a fraction. And we already saw this king of hearts. This guy's not a king of hearts. So there are only 3 kings left. And we already saw the king of hearts. So they can't be the king of hearts. So there's not 52 cards left anymore. There's 51. So the probability, whoops, I want to put it here. Probability that the second is a king. Yeah, no, I didn't return it. It's still sitting here. Do you see that? There's this one that we don't see and the one that you do see. Yeah, we're not returning them back. That's different if you return them back. The probability the second is a king given the first is a king is 3 out of 51. So I want to let you know that this little line segment, this vertical line segment thing, it's read as given, G-I-V-E-N. So we know that the first, or we're given the first is a king. Now find the probability the second is a king. Any questions on that? Okay, so now what we're going to do is we're going to use what's called the multiplication principle. And that says the probability of A and B is equal to the probability of A times the probability of B given A. So the good news is we've done all the work. Okay, this is a very important formula, so I put it in red, it's dark. Probability of A and B equals the probability of A times the probability of B given A. Okay, so now we can actually work this out and say, let's go and find it. So let's make let's do this. I think the easiest is I'm going to write probability of A, which is the first is a king. I'll copy and paste that one in. And then we're going to go times. I typically use a star for times. And now we're going to multiply by the probability of B given A, which was 3 over 51. Any questions on how I got that going? Any questions? I think I'm going to show you something that's going to be helpful. And that is if we go to the calculator, and it turns out you could use almost any of these. I just go to one variable stats calculator, it doesn't matter. But on the bottom of the calculators, I have a button that says scientific calculator. If I click on that, that gives me a nice calculator to use. Okay, so if you need more than what, if you need arithmetic stuff done, then that's what the scientific calculator does for you. So that, now I can just type in, and that was, if you remember, let me show you, 4 over 52 times 3 over 51. Four over 52, and then times 3 over 51. I don't even have to enter anything, it just gives it to me. And that probability is this messy number, 0.00452, etc. And there's our answer. Very unlikely, by the way. Okay, it's really hard to get 2 kings if you randomly pick 2 cards. Any questions on this example? Any questions? I want to give you a big heads up about this chapter, and I like to relate it to one of the other things that I used to teach besides math. Any guess on what I used to teach? That wasn't math? My guess is you won't guess. Okay, no, never taught science. Good try. No, I know nothing about cars. Don't ask me anything because I won't know. No, you're not going to guess. Not econ. Should I tell you? Martial arts and, karate. So I like to think of this very much like kickboxing. It's very different to watch someone else do kickboxing than to do it yourself. It's very easy to sit in an audience and watch a couple people, do some kickboxing. But trust me, you get in the ring and then everything is more difficult and painful, could be painful. So I want to let you know that probability is often like that too. Watching me do it is really easy. And then you go to the homework and it's much harder. So beware and be ready to practice, practice, practice. Also be ready to get help from the tutors or from me during my student hours and make sure you can, understand it and be able to work this out. Any questions? Any questions on anything I've done so far? Okay. So yeah, so by the way, don't try to fight me because I'll probably win. because it's what I was good at. Okay, so suppose you pick five cards now. So one of the things, hopefully you know this, besides skiing and our lake, what is Lake Tahoe like known for? Well, in terms of our economy, beer. I don't think we have beer, but fishing, that's our lake, is fishing. Gambling. We have casinos, lots of them, because Nevada has casinos are all legal in Nevada basically. So I figure I can do some casino stuff because that's where we are. I know a lot of you aren't in Tahoe, but that is part of Tahoe. I can walk to the casino and it takes a while to walk, but it's just, 40-minute walk and I can walk to the casino, drive in 5 minutes if there's no traffic. So poker. Okay. I actually used to teach a class called the mathematics of poker. So let's suppose you pick five cards, but here's five cards. I randomly picked them. What's the probability of getting a royal flush? Now, who knows what that means? Put in the chat box if what a royal flush means. Because some of you have played poker and know about it, and some don't probably. So I figured maybe you can help each other out. I can't imagine nobody knows. Yeah, same suit of all face cards plus an ace. So for example, an ace, king, queen, jack, 10, all of spades. And they could be in any order in your hand. Okay, it could be hearts, doesn't matter the suit, as long as they're all the same suit and you see all the face cards and the ace. So we want to find the probability of getting a royal flush. Okay, that's actually quite difficult. Okay, so what I'm going to do is first thing is probability is a fraction, and we can say how many royal flushes are there? Okay, well, there's the royal flush of hearts, the royal flush of spades, the royal flush of clubs, and the royal flush of diamonds. Is that clear to everyone? Because could have any of the four suits. So the numerator is really easy. It's just a 4. Now comes the denominator. Okay, and remember, the order doesn't matter. So we have to have ace, king, queen, jack, 10 in any order. Okay, so how do we come up with it? Any thoughts? And here's the key. We need the calculator. So I can go back to the calculator and I am going to be using combinations and permutations. As I mentioned last week, I made this calculator in the order at which we did things. Last week, we talked about what a random number is. We looked at the statistics and also frequency table. You might have some homework problems on that. We looked at z-score. Now we're on combinations and permutations. All right, so how many cards are there in the deck? 52. That's n. So n are the number of things to choose from. Okay, we're playing poker. How many are we picking? 5, because there's 5 cards in a poker hand. Any questions so far? Okay, now there's 2 choices. It turns out NPR is when order matters. Sorry, PNR is when order matters. So that would be like if you had ace, queen, king, jack, 10. If that didn't count as a royal flush, then order matters. Does that make sense? But in poker, if you have an ace, queen, king, jack, 10, all the same suit, that's still a royal flush. So when order doesn't matter, we're going to use what's called combinations. When order does matter, you use permutations. So if I click CNR, it gives me the answer. And that's how many different 5-card hands there are in poker. Okay, and it's not something you're just going to be able to list them all because it's 2,500,000 98,960 different poker hands. Any questions on how I did that? Yeah, if you play poker and the house wins, just let you know, it's partly my fault. They actually, when I moved up here, they paid me to help them change the rules so that card counters, like I used to be a card counter, can't win anymore. So if you think you're going to make money playing in the casinos, think again. Your probability is really small. So to get a royal flush is 4 out of 2.6 million-ish, which is very unlikely. Okay. Okay. And that's in just the first 4 or 5 cards. If you have choices, like you can, get 2 new cards out of it, that's harder. And it's not elementary statistics, it's advanced statistics. So we don't do that. Any questions on that? Any questions? Okay, so this is important, not just in playing cards. Let me give you, I don't think I'll do the examples, but talk about some other examples. Let's suppose that you have a baseball team. Oh, the numerator is 4 because you can have spades, diamonds, hearts, or clubs. So there are 4 different winners that are royal flushes. Do you see that? Does that make sense? So that's why there's 4 for the numerator, because there's 4 ways of winning. Is that clear? Okay. So another example, let's throw baseball into it. Actually, I'm not an expert on baseball, but on a team like the Dodgers or something, or whatever you like, the Giants or something like that. How many players are there? Not that are playing, but that are in on the whole team. There's a lot of pitchers. There's a whole lot of people. Any guess? Just throw a number in. I don't care. Okay, 40. Okay. So then if you say, well, let's suppose out of 40, if you're going to randomly select 9 of them to be playing, then you would do 40, you do C 40 comma 9. And that would be how many different groups of 9 players you can have out of 40. Okay. It's a lot more complicated because you probably don't want your pitcher to be your first baseman or something like that. But not getting into the complications, that's all it is. So anytime you're picking a small group out of a larger group, and order doesn't matter, you can always do that NCR or CNR. Any questions on that? All right, now let's do another example. Okay, so let's suppose that you guess randomly on a 20 question, 4 answer multiple choice quiz. Find the probability of getting them all correct. Okay, so if it's if it's a multiple choice, and you know nothing, then it's better to guess than to do nothing, right? Than to leave them blank. Okay, and that's true in our class, by the way, too. Okay, on the exams, don't leave it blank because you leave it blank, you can't ever get it right. If you at least get your best guess, you have a better chance. So if there were 20 questions and each one had 4 choices and it was all multiple choice, what's the probability of getting them all correct? Any questions on the question? Do you think it's a high probability or a low probability? What do you think? You think it's a high probability? You think it's a low probability? It turns out it's going to be very low, but let's work it out. So, what's the probability of the first guess being correct? That should be really easy. You guess on problem number 1. What's the probability of getting it right? 1/4. Okay. How about the second one? What's the probability the second one is right? 1/4 again. How about the third one? 1/4 again. Okay, and by the way, if you guess the first one right, does that change the probability of guessing the second one right? If you're totally guessing, doesn't change it at all. And similarly, if you guess the first one wrong, it doesn't change the probability in the second one wrong. Okay, and when that happens, then we can just multiply. So the probability of getting all 20 correct will be a fourth times a fourth times a fourth times a fourth times a fourth, all the way up to a fourth. And that 1/4 will be there 20 times. And the easy math way of writing that is 1/4 to the 20th power. Any questions on that? If I pop that into the calculator, oops, hit the wrong button. Let's try one more time. Scientific calculator. I'm just going to take parentheses 1 divided by 4, end parenthesis, to the 20th power. Okay, so is the probability 9.09? Yeah, it's not. Okay, probabilities can never be bigger than 1. You can't have a 900% chance of winning. Do you see? So what did I do wrong when I just said, oh, the probability is 9.09 or so? What did I miss? And I'm specifically saying because it's common to miss that for students. What did I not look at? Yeah, scientific notation. So this calculator uses times 10 to the negative 13th power. Okay. If you look at some other calculators, including mine, by the way, it'll usually use E and then negative 13. It makes it a little easier to handle because then you don't have a number next to a number. You have an E. So just let you know that that's another way of writing scientific notation. But if you're ever asked for a probability, never say it's bigger than 1. It can't ever happen. Got it? So find, and it's usually looking to your right. And by the way, just note, if you're using your smartphone, smartphones have smaller screens. So sometimes they'll only show these first bit. And you won't even see that 10 negative 13 or the E negative 13 unless you scroll. So that's a big heads up, is that if you ever see a probability being greater than 1, it's not. It probably means you need to scroll and look to the right. Any questions on that? It's a real common mistake. So don't make that mistake. Okay, so now I'm just going to write 9.09 times 10 to the negative 13th. The way you can write that is 0. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 909. And that is a probability, which is tiny. Okay? In your lifetime, even if you tried it like every hour of your life, you have a very tiny chance of even ever getting 20 questions right. That's how small this number is. Any questions at all on this example? Okay, let's look at the next one. Okay, or before we look at the next one, I want to give you some vocabulary. If you're allowed to repeat an answer, it's called with replacement. So on that multiple choice question, you're allowed to repeat. So you have 20 questions and you could guess all of them are A. And that's allowed. You could have the second one being A even if the first was A. Okay, and then we call it with replacement. So if you're allowed to repeat an answer, we call it with replacement. Got it? Okay. On the other hand, if it is also if it is with replacement, then the probability of A and B equals the probability of A times the probability of B. Okay. Any questions on that? And in a little bit, we're going to note that when you have that equation being true, then we'll say they're independent. Any questions on that? Any questions? Okay, so now we got the lottery ticket. Okay. And by the way, it's millions and millions of dollars if I win the lottery, right? So what do you think? Should you go into my office and, better bring a gun because I know martial arts, but should you steal the lottery ticket from me? Because hey, if you win, you're getting millions and millions of dollars. Tens of millions. What do you think? Is it a good idea? Okay. And well, morally, hopefully, it's not a good idea, but even statistically is a good idea. So what's the probability of the tickets of winning lottery? Okay. And let's suppose that this has the way you go, at least when I
Holy shit,
bet on
dude.
the lottery, then sometimes I'll buy more than one, and I'll explain that next week. Why sometimes I buy some tickets. Okay. By the way, the word zillion is not a number, just let you know, because we actually need to find one in what. Okay. And first thing, it'll be not one in, it'll be two in. Okay. Because I bought two tickets. So the way they do, they randomly pick numbers, and two of those that come out, there's two possibilities for me to win. Do you see that? So here's what we do. First thing is you have to know the rules. And what you may not have noticed, this is a Powerball lottery. And the way that works, you could look it up online and see, is you pick five numbers between the numbers 1 and 69 and one between 1 and 26. Okay. So let's find the probability. So what we're going to do, and I have the numbers here, but I'll show you how I got them. The numerator is 2 because I bought two tickets and there's two ways that I can win. You see that? The denominator, we got to say, well, how many ways are there of my five numbers being picked? Does that make sense? Or how many, in not my five numbers, how many ways are there of them picking five numbers? What should I do to find out how many ways are there of picking five numbers out of 69 numbers? Any thoughts? The hint is we've already done it, kind of. We go to the calculator, and it's the same calculator. But now there were 69 choices, and we're picking five numbers. And I calculate, and I get 11,238,513. So that is where I got this number here. Okay, just let you know there's a math equation for doing this too, but this is elementary stats, so you're not responsible for it. And I'm going to be telling you that all the time in this class, that just use the calculator, but you have to know which calculator to use. And if it's how many ways are there of a group happening out of a larger group, then that's going to, when order doesn't matter, that is that combinations calculator. Okay, but then we have the power number because we also pick a number between 1 and 26. Okay, and it turns out that, let's say they picked 12 for the first number. The second number could also, they picked 12 for the first number. The power number could also be a 12. They don't throw that number away when they're picking the power number. But of the five numbers, those are, individual. So what we do is we multiply this denominator by 26. Any questions on this? Okay, and if you work it out, stick in a calculator, you get 0.0000000064446 is the probability of winning the lottery. Okay, what do you think? Is that a pretty high probability or a low probability? Yeah, it's a really low. Okay. I will tell you that I did not, this is not a current ticket. I'm not silly enough to, next week we'll learn when it's a good, maybe possibly a good idea to buy a ticket. Um, and right now is a terrible time to buy a ticket. But next week you'll learn what that means. And that's when we're going to get into what's called expected value, but that's next week's stuff. Any questions on winning the lottery? Okay. Any questions? Okay. So if there's no questions, now let's do another example. And I want to give you a heads up about this chapter. There's lots of word problems. So you do have to know how to do word problems. So I'm going to do an example of a word problem, and then they're all going to be exactly the same example, but they're all going to be word problems. And they typically have a big paragraph like this one is. So let me read it. So I recommend this as a step-by-step process. Step one is read the question. So suppose that 20% of all students taking stats at LTCC are African American. By the way, if I say suppose, it means I just made it up to make the numbers nice. Just let you know, don't quote me on it like, hey, it's 20%. I think it's probably a little less actually. But let's suppose because it's an easy number to write. And 40% of all students at LTCC are non-STEM majors. If 22% of LTCC students, non-STEM majors, are African American, and you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. So step one is read it. Got it? That's usually not hard, just to read it. Step two is where it starts getting hard. Step two is to read it again, but this time go slowly. And every time you see a number, write down an equation for that number in symbols. So suppose 20% of all students taking stats at LTCC are African Americans. Okay, I'm going to use the letter A for African American. Seems like it works. First letter. So I'm going to write P parentheses A is equal to, well, 20% is 0.2. Any questions on that? Okay, now we read a little bit more. 40% of all stats students at LTCC are non-STEM majors. So I'm going to let N be non-STEM. And then P parentheses N parentheses, will be 40%, which is 0.4. Much better to use decimals than percents, by the way. Percents will mess you up. Okay, and always remember that you move the decimal over two places. So if it was, 2.5%, that would be 0.025, not 0.25. Okay, so let's read more. 20%, 22% of LTCC student non-STEM majors are African American. So that means of those who are not STEM, 22% are African American. So we're taking the large population and we're restricting it to non-STEM. That's what given is all about. So we're going to say the probability of A, of being African American, given they're not a STEM major, N, that will be 0.22. So let me ask you, any questions? Any questions at all on getting those numbers and writing them with symbols? If you don't do that, it's pretty impossible to do these problems. Any questions at all? And again, the big warning is this is just like kickboxing. It's very painful to do it yourself, not so painful to watch someone else do it. So this stuff is like that. Okay. Then I'm going to read a little more, and this is something the next step, and that is write down the goal in symbols. And the goal is if you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. So we're given they're African American. We want the probability of non-STEM. So that's P parenthesis N, line segment, which means given A. And I write equals question mark because that's what we want to find out. Any questions? Any questions on this? Okay. So now there's these important formulas, which we've kind of already saw. We're doing it again. Probability of A and B is equal to the probability of A times the probability of B given A. And by the way, A and B versus B and A, that's the same meaning, right? Is that clear? Right. If I told you someone is living in Tahoe and they are a college student, that's no different than saying someone is a college student and they're living in Tahoe. So switching the order on the and doesn't change anything. Is that clear? Okay, so that's why I'm able to switch that. Okay, so here's a very important formula. If I take this second formula and I divide left and right by probability of B, I get this new formula. And that is the probability of A given B equals the probability of A and B divided by the probability of B. Any questions on that? Any questions? Okay, so now what we can do is we can take all these formulas and we can take the probability of A and B equals the probability of B times the probability of A given B. But the letters don't matter as long as you're consistent. Instead of B, I can use N. That doesn't change anything. It's just the letter. Other than making sure everywhere I see a B, I put an N. Do you see how that works? So probability of A and N is equal to the probability of N times the probability of A given N. The probability of N is 0.4. So I put a 0.4 here. The probability of A given N, that's 0.22. So I put a 0.22 here. Any questions on that? Anyone lost? All right, so now, again, my goal is the probability of N given A. So now I write probability of N given A equals, and I use that formula. That's the probability of A and N divided by the probability of A. You always divide by the second letter, not the first. The thing that's given is what you're dividing by. And then I just plug in probability of A and N. That was this 0.4 times 0.22. So I just put that up here. The probability of A, that was 0.2. So I put that down here. Any questions on that? And then it's basic calculator work. You get 0.44. Or there's about a 44% chance that if you randomly select an African American, then the probability of them being non-STEM is 0.44. Anyone lost on this idea? Okay, let's go to, I think I'm going to skip this one because of time. I want to do what's called a contingency table problem. Okay, so I'm going to do it by example. A survey was done, and by the way, I made this up so we can pretend a survey was done, asking Lake Tahoe Community College transfer students where they plan on transferring to and what living situation they will be in when they transfer. And this table gives you the results of the survey. So let me explain how you read this, for example. So this 7 right here, what that means is of all of the students who were surveyed, 7 plan on transferring to UNR, which is University of Nevada, Reno, and will be living with their parents. So not very many of them. Any questions on that? Okay, so that's how you read this kind of table. This is called a contingency table. And here's the question. Find the probability that a randomly selected student will go to a UC campus or live in an apartment. And note that if you add all these numbers up, just to save you time, I got 246. Any questions on the question? Any questions? Okay, so here comes another big formula. Today's a lot of formulas, by the way. And again, you're welcome to write it on a piece of paper so that when you're taking the exam, it's right in front of you. If you don't, it might take too long and you might run out of time. So I strongly recommend having the formulas on some paper. So here's a big formula, and that is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay. The idea is if you add the probability of A and the probability of B, if you add those two up, and there's something that's both A and B, then you've double counted that one, that person. So that's why you subtract the double counters, and those are the A and B's. So we can take that and we can turn that using different letters. So we want the probability of going to a UC campus or living in an apartment. So I'll use UC for UC campus. And how about A for apartment? So we want the probability P of UC or A. And that's going to be P of UC plus P of A minus P of UC and A. Any questions? Okay, so now we find what's the probability of randomly picking a student and going to a UC campus. And the key is we go back to the very, very first thing we did in probability today, which is write a fraction. How do we find how many students are going to go to a UC campus? It's really easy. Using the table. What do? How many students plan on going to UC campus? Not too hard. There's a little math. Yeah, we take 33 plus 8 plus 19. By the way, 33 plus 8 is 41, plus 19 is 50. Okay, and then I told you, just to save time, that there were 246 total students. So the probability of UC is 60 over 246. Probability of A, okay, and that probability of A, that's living in an apartment, will be 43 plus 33 plus 19 plus 22. And then we divide by 246. When I add all those up, I get 117. And then you divide by 246. Probability of UC and A. So that means they're right here. There's 33 of them that are going to transfer to UC campus and live in an apartment. So the probability of UC and A will be 33 over 246. And in the formula, we add and we subtract. And I'm going to save the time and just tell you this is what I got when I put in a calculator, which is 0.5854. Any questions? Was that too fast for you? Was that okay? And the big warning is doing it yourself is so much harder. But by the way, this will be on YouTube. You can always, watch it again. It's a good thing about YouTube. That's one reason why I post it. In fact, even when you're done being a student here, you can still watch it in years. It'll still be there. Okay. Now comes two very important definitions. Two events, A and B, are called mutually exclusive if the probability of A and B equals 0. Okay? So let me give you an example, kind of an obvious example of being mutually exclusive. Let's suppose let's say we're going to randomly survey a college student. Got it? Okay. And how about a college student at Lake Tahoe Community College? And let's suppose A is the event that the student was born in California. And let's suppose that B was the event that the student was born in Nevada. What's the probability of A and B? The hint is it's very easy. If A is the event they're born in California, B is the event they're born in Nevada, yeah, the probability is 0. You cannot be born in both states. It's not how birth works. Is that clear? Okay, so those would be mutually exclusive events. They can't both happen. Do you see that? That's the idea of mutually exclusive. How about transferring to a CSU and living with parents? Are they mutually exclusive? Well, that's really easy because if we go back to the table, there were 34 students who transferred to a CSU or want to transfer to CSU and will be living with their parents. So the probability will be 34 over 246. And 34 over 246, you don't need a calculator to know that's not 0. Is that clear? So they are not mutually exclusive. Often, I don't want to just say it's all about me, but often we use ME for mutually exclusive. Any questions on that? So mutually exclusive is pretty easy. Okay, then the next definition is two events, A and B, are independent if any of the three following are true. Okay, if one is true, they're all true. If one is false, they're all false. One is probability of A and B equals the probability of A times the probability of B. The next is the probability of A given B equals the probability of A. And the third is the probability of B given A is the probability of B. Okay. Any questions? So you only have to check one. And my recommendation is check the one that looks easiest because you only have to pick one. So are living in an apartment and transferring to UNR independent? So just to note that the first one has 3 probabilities involved. You see that P 3 times. The other two only have 2 P's. So if the probabilities are all kind of the same difficulty, you might as well pick the second or the third one. So I'm going to go probability of living in an apartment given UNR. So let's look at that. Okay, so if we're given that they're going to UNR, that means we're only looking at this column of the UNRs, 19, 7, and 15 for apartment, parents, and other. Okay, and the total number of them will be 19 plus 7 plus 15. 19 plus 7 is 26. 26 plus 15 is 41. Any questions on that? That'll be the denominator. Okay, on the other hand, living in an apartment and going to UNR is 19. So what we can say is the probability of an apartment given UNR is 19 over 41. And I think the easiest is to actually use a calculator and divide. You get about 0.46341. On the other hand, living in an apartment, that's 43 plus 33 plus 19 plus 22 divided by 246. And that is 117 over 246, which is 0.4756. Not too far apart, but they're not the same. If they're not the same, they are dependent. Got it? Okay. Any questions on the calculation to decide if they're independent or dependent? Okay. And by the way, if I ask you to give your reasoning using calculations, you need to do these equations. Don't just do it in words. Okay. Kind of the idea of being independent is if you know about one, that doesn't tell you about the other, because that's what this probability of A given B equals the probability of A means, is knowing B doesn't change the probability of A. Do you see that? So kind of an example I like to give kind of in theory is, let's suppose that A is the event that it is snowing in Tahoe. And let's suppose that B is the event that the high school soccer team at the kind of the biggest high school in Sydney, Australia, wins their next game. Okay, those are probably independent, because knowing that it's snowing in Tahoe is probably going to tell you nothing about whether some team in Australia is going to win. Does that make sense? Okay, so that's kind of the feel for independence. That's not the calculation, but that's the feel. Any questions at all on independent and dependent? And by the way, the opposite word for independent is dependent. So you could write not independent, but most people just say they are dependent. Any questions at all on this example and this definition? Okay, so the next thing I want to tell you is a secret word. Very easy one, 2 letters, or. Because or is one of the words in probability, right? Probability of A or B. I always try and do something that you wouldn't just randomly guess, but comes from something we did. So the secret word for this week is or. And just let you know, if you complete the secret word quiz, and if you're listening to this, you better. If you complete the secret word quiz by Sunday, get your point for it, then you don't have to send me notes. If you don't complete the secret word quiz, then you do have to send me notes by Sunday. Okay, so that's just a note. Some people were confused about that. Any questions about the secret word being or, O-R? All right, so now what I want to do is, we're done with talking about probability. It's time to talk about project. So again, the first step of the project is something that hopefully all of you, but I know some of you may not have yet, is find two partners is best. So a group of 3. You could do a group of 2, but a group of 3 is better because it's less work. It's almost impossible to get a passing grade on the project if you do it by yourself. So do not even think about doing your project by yourself. Any questions on that so far? Okay, so just to note where I am right now, if I go to the homepage, by the way, I've changed it. Now goes to the modules, because that's what you're going to mostly do every week is the modules. And we're in week 2 actually right now, right here. But if you want to kind of find out the project, I think the best way to do it is go to the syllabus, and that I click on syllabus. and then scroll down until we see projects. So now we talked a little last week. Now we're going to talk enough so you're ready to do it. Okay, so 2 projects are going to be created. We're going to be today we only talk about project 1. Okay, and you're going to collect quantitative data. Who remembers what the word quantitative means? Very important word, quantitative. Yeah, it means that the answer to the survey question, and by the way, you have to collect the data by doing a survey. Um, and the answer to the survey question is a number. So, what I recommend once you've got your partners and you've got your idea for your project is ask your partner the survey question. And if they say the word yes, your survey will not work because that's not a number. If they say the number 43, there's a good chance your survey will work. Does that make sense? Okay. You're going to use a computer to display each of the charts discussed in the class. And you're going to use a spreadsheet. And you need to use this Google Sheets program. And if you click on that, by the way, you need to click on the starting out button right here. And then I showed you this last time. You go to File, make a copy. Give it a name, hit make a copy. I'm canceling because I don't want a copy, but that's your first step. Your next step probably is to go to share and then share it with your partners so that all of you are seeing the same spreadsheet. Okay, this is Google Sheets. And I created this many years ago, but it is used by like a million people now. So then the next step is to highlight all the numbers in column A and hit the backspace, and that way you're starting from fresh. Okay, so that's how you use the spreadsheet. And then you put your data in. Okay, and that might be, I don't know, 44, 33, 24, 55, 41, 38, 32, 33, etc. Okay? So just to note, that's how you put your data in. Okay? In your final submission to your project, something you're going to have to do is absolutely required is you're going to have to make a screenshot of kind of this important stuff right here and then copy and paste that into the project. So that can be in a Word document or Google Doc, whatever, but it has to be copied and pasted in. You have to show that you use the spreadsheet, and that's how you show it. Okay. You could also do screenshot copy. You can do it that way. There's a bunch of ways of copying a piece of a screen. Any questions so far? Okay, so let me go back. Okay. All right, so let me click on project 1, and now it's going to go over all the things you're going to have to do. Okay, so let me talk about all the different things. And please ask questions as you go. So this is a step-by-step process. Step 1, I hope you've done already. What was step 1? Yeah, find partners. Okay. Here's something I want you to do in the chat box. Okay, or on paper if you are watching this not live. And that is, I want you to say, I promise I will work with partners. Can you put that in the chat box? Most of you don't like breaking promises, so that maybe that'll help. I'll tell you, last quarter I taught this, you don't know how many students didn't do partners. And you don't know how many low grades there were. And I don't like giving low grades. So this is a biggie. If you don't work with partners, it's almost impossible to pass. In fact, I think everyone who worked with partners passed, and everyone who didn't pass in the project 1 last quarter. Okay, so that's just a big note. Okay, good, good. So that's the first thing. Have a partner. Okay, step two. Step two is to go to the project, is to talk to your partners and come up with your idea. Okay, let me talk about what's involved in the idea. Okay, one is you have to do a quantitative survey question. Okay, so that's going to be a survey question. You have to identify somebody who, at least in theory, might contract you out to conduct this study. If nobody would be interested, then the project won't work. Okay. This is in theory, so you don't actually have to get the person. So it could be, I don't know, the governor of California. Okay. Even though I doubt you'd be able to, I couldn't contact the governor. Then Newsom wouldn't answer my email probably. Okay. It could be the president of the United States, even though Trump wouldn't answer my email either. But you could pretend they did. Does that make sense? And that they need it. Okay. Or it might be, I don't know, the manager of the restaurant you work at. Okay, got it? Okay, so it has to, if no one's interested, then it won't work. Is that clear so far? All right. So then after you decide who's going to do it, then you're going to have to do a survey. And you're going to have to decide, I'm going to write this here, I'm going to show you here on the sampling technique that you're going to use. And here's the choices. You must either use simple random sampling, and I want to let you know that's not going to happen. It's impossible, so don't do it. Or stratified sampling or cluster sampling. I have links in case you need to remind yourself what those mean. They're very important. And so you have to use one of those sampling techniques. That is a requirement. Okay, I think a lot of people say they use random sampling, and boy, do they lose points because they didn't. It's, like I said, almost impossible to use random sampling. Okay. I think maybe once in my career did someone do it right. So instead, stratified sampling, which is not that hard, cluster sampling, also not that hard. Okay. So you have to decide on the sampling technique. Okay. And how you're gonna apply that or make it happen. Then my strong, strong recommendation, once you've done that, okay, maybe you can do that by the end of the week this week. Okay, if you have shouldn't take more than a week to come up with a survey question and a sampling technique in your client. Then what I want you to do is go to the Project One discussion board and post your survey question that you're going to ask, who your client is, and how you're going to conduct your survey. And by the way, you should also decide on what your population is. Okay? It probably won't be all people on Earth because good luck having any chance of having a good study of all people on Earth. Okay, it might be, say, California community college students. That is a possibility because they're not too hard to ask. It might be all the customers that ever come to your business if you have a business with thousands and thousands of customers. Does that make sense? So decide on who your population, the population needs to be large. If the population is not large, there's no reason to conduct a sample. Then you can just do a census, and that doesn't work for the project. Got it? Any questions so far? Okay, once you post it in the Project One discussion board, which I recommend maybe by the end of the week this week, I will take a look at it and I'll give you comments. Hey, this works great. It's wonderful. That's usually not the comment that you get. Usually it looks pretty good. Here's one little thing that I recommend changing. Do you see? That happens a lot. And then occasionally, which you don't want and I don't want, and it's that this won't work. Your survey question is a yes, no question. And that doesn't work because that's not quantitative. Does that make sense? So find something else. So I'll give you feedback on whether your idea will work or not. Because if the idea won't work and then you go and try and do it, you're going to totally waste time. Any questions on that so far? Okay. Then what you're going to do after you get I say it's going to be good, then you conduct your study. You do your survey. Okay. So there's going to be a few things about doing the survey. One, this is very important, is the sample size must be greater than 30. And just a note, 30 is not greater than 30. What's the smallest number greater than 30? 31. So if you want to make it easy, go 31. You don't get more points if you do 100, by the way. Okay? So 31, 32, if there's three of you and you want to break it even and not have one have to do more work, then do a 33 and then you all do 11. You see that? That's fine. Okay, the only reason to do a much bigger number, anyone know what the only reason? And it does happen sometimes. Any guess? I don't see it, so let me tell you. And it happens once in a while, not very often, but once in a while. Sometimes your project is going to work really good for your job. And your boss might want a bigger sample size. And your boss is paying you, so you're okay with it. That occasionally happens. Okay, not too often, but once in a while we get that. So you actually get a survey. You do a survey that's actually useful for your work. Okay. And occasionally. Any questions on the sample size? Okay. So then you conduct your survey, and I want to mention a few things. One is it is against a lot of survey children without intense amount of signatures from parents that is way too hard for me to even discuss. So don't survey children. Okay, if they're under 18, don't survey them. The only time you're allowed to say survey a 17-year-old if they happen to be a college student and you're at the college, then their parents have signed off. Then you're allowed to survey them. But if they're not a student at a college and they're under 18, don't survey children. Got it? Because there's all kinds of laws against it. Any questions on that? Okay, believe it or not, I found out a really bad way a long time ago that someone surveyed children. You don't know why? Any guess? I came home, had my daughter, said, one of your students asked me a survey question. She was in high school at the time. She was like 15 or 16. It was a lot of years ago, but still, it was pretty weird. It's like, no, I told them over and over again. So, yeah, and this is, by the way, we're being recorded. So if anyone sues, I can't get sued because I've told you, and this will be on YouTube. So I have evidence. So don't survey children. Got it? Okay. So that's what you're going to have to do. And then once you've done your survey and collected your data, you're going to pop it into the spreadsheet program. By the way, it has to be this spreadsheet program. It cannot be the other calculators I showed you. It can't be some other spreadsheet program. This is the requirement. So it has to be the spreadsheet program. This has everything. All you do is look. And it has the minimum, the mean, the sample variance, sample standard deviation, the median, the maximum, Q3, the sample size, Q1. It just has it all. You don't have to do anything. It just shows it to you. It's really easy. Okay, so once you have done that, then what you do is you need to you need to also make charts. And the charts have to be, you have to have a histogram, you have to have a stem and leaf plot, and you have to have a box and whiskers plot. Okay. Some of your computers may not allow you to do that using stats, say stem and leaf. Mine does. And if it doesn't, then I have some other links that you can use instead for the charts. Any questions on that? But this is really easy. By the way, all this wording stuff, don't worry about the wording. That's just if there's a blind student, that way it is accessible unless you're blind, and then the wording is there for, and you can actually read what the stem and leaf tells you. And same thing with the others, because I tried to make it as accessible. Okay, and the question is, what are these for? Again, some of your computers won't let you do it with my computer, with my worksheet, because it'll tell you there's a virus and it won't let you open. And there's no virus, by the way. I promise, but some computers don't understand it. And then you can try one of these instead. That's the reason why I put this there. Okay, any questions on that? Okay, so that's just a note. You have to have those. I want to mention something about stem and leaf. Stem and leaf does not work if all the numbers are one digit, because then there's not a stem and a leaf. Is that clear? So if you think a survey question like how many siblings do you have works, that's not going to work, because if you randomly ask 31 people, you almost never get anyone with more than 9 siblings. Do you agree? You're not going to get 2-digit numbers. Is that clear? So make sure that a good bulk of the answers are going to be at least 2 digits long. Is that clear? They can be decimal points, and that works too. You just have to change this S and L left 10 power. Okay, and I could help you with the tutors can too if you're stuck on how to do that. But again, 1 digits don't work. So don't do on a scale of 1 to 10. That really doesn't work. Okay, make sure that the answers are multiple digits. 2 works really well. Any questions on that? Okay, and by the way, what I want you to do is I want you to copy and paste or do a screenshot of each of the diagrams, the histogram, the stem and leaf, and the box and whiskers. And I want you to put them directly in the project so that you can refer to them and I can see them when I grade them. So that is important too. Okay, and every computer has a screenshot feature. Okay, so hopefully one of you guys knows how to do it. If not, I can help or a tutor can help. Any questions so far? Okay. All right, so you must have that. Okay. And again, I'm not reading every word here, so and you should read all the words, but you should be talking about the bias. That's important. You should be talking about, it's a little like the discussion post that you do last week. Talk about the bias. You should also talk about if you can conduct a survey and you had more time and money, for example, then how might you reduce the bias? Any questions on that? Okay. And that doesn't mean you have to. It just means that you talk about how you would reduce the bias. If you think there's no bias, think again. There's always bias in pretty much any survey where you're asking people. I want to give you a couple more, I don't know about legal, but responsibility things. One is if the survey is going to be a classroom, make sure you get permission from the professor before you do the survey. They'll almost always say yes if you tell them what it's for, that it's for your statistics class, but you should ask. Does that make sense? If it is, let's say you're doing surveys of, I don't know, people at Safeway supermarket, make sure you ask the manager. And again, if you tell them you're a student doing this, they'll almost always say yes, but make sure you get permission. And if you work there, especially, because I don't want anyone getting fired because of this project. So make sure you get permission first. Does that make sense? Okay, so that's important. Okay. So those are the main things. Then you're going to do once you've got that, then you're going to start doing the writing. And it's a paper. So that means it is going to have a introduction, then it's going to have the main content, and then it'll have a conclusion. I want to let you know that good papers are usually like 8 to 14 pages long-ish. You know, that if you do a paper that's 2 pages long, it'll almost never be good enough. Okay, there's a lot of writing. So make sure you have writing because you're going to have to interpret everything. Okay, one little piece at a time, not in general. And then throughout the entire paper, explain how your client is going to use that piece of information, whether it is, say, the median or the box plot or the stem and leaf. What decisions will your client make based on what you just looked at or what the client just looked at? It's all about the client. The client is your audience. Is that clear? Okay, very important. Okay. You have to have all the summary statistics. And as I mentioned last week, the standard deviation is a biggie. If you don't have a full paragraph on the standard deviation, you can't get an A. Okay. You should include either the empirical rule or Chebyshev's theorem, depending on whether you have a normal distribution or not, and make sure you talk about it, usually based on the histogram. Okay. And explain the decisions the client will make based on it. Which one works. Okay. You should talk about the Z-score. Okay. And don't just let the computer, if you look at the computer, let me show you something. When you go to Z-score, you have an X value and that'll give you a Z-score. See these words? Change this. Don't just use what the computer has. That's just some random number. Use what works for your client. And not just one, but a few. One thing you got to decide if you have outliers. Find the Z-scores to see if you have outliers. Those are going to be the big numbers and the small numbers. Find out if you have an outlier. And then explain how the client is going to use that information to make decisions. Is that clear? Okay, a lot of things to do. That's why it's a long paper. It's not a short one. But again, if there's 3 of you and it's a 9-page paper, you only write in 3 pages. You're reading 9 because you should read the whole paper before you turn it in, all of you, and then help each other. Any questions on that? Okay, again, there should be a synopsis of your findings, and the key recommendations kind of at the end is a good idea too, but recommendations throughout the whole paper on everything. Okay, I'll let you read the details, but that's the idea. Okay, and then you should talk about how would you conduct a further study to give more information for your client. Okay, and that could be additional survey questions. You're only asking one survey question, by the way, in this project. But you can talk about an additional study, or how might you make the study better in terms of your sampling technique so that the bias isn't so bad. Any questions on that? Okay, so lots of things to do. Lots of things to do. Okay, any questions? How should it be formatted? Okay, so one thing is I'm not that strict on the English. I mean, it better be readable. But the one thing for sure, the very top, what should be at the very top of your paper? This should be obvious. What few things? This is obvious. Yeah, your names. Don't forget to put your names on. If it only has one person's name on, that means you lose 25%. So names, date if you want. I don't care about the date, and a title. Yeah, you can put a date. It won't hurt you, but name and title for sure. Okay. I'm not that harsh on, English and stuff. It better be readable though. And if it's got all kinds of problems, that's bad. I might take 1 point off. It won't be 100% if you make a spelling mistake or something. Because computers usually fix spelling. Okay. You should have references for if you're referring to anything. But I'm not strict on the structure of the reference. So providing a link is probably fine, or whatever works, make sure you refer to anything you're referring to. Does that make sense? Does every person in the group, okay, only one person in the group submits the assignment, but make sure that everyone's name's on it so that I can give everyone the, credit for it. So works cited page, so either you could have a page or just at the end, just cite it, or during the paper, cite it. I'm not picky on that part. Does that make sense? You should cite, but I'm not picky on the structure of the citations. Does that make sense? Any questions on those ideas? Okay, then here's a big deal. Okay. Before the project is due, and I want to let you know one thing that about this project. I'm teaching two sections, as you, hopefully you know, because you're not all in the same section, and there's a lot of students. Okay, and if the paper's 10 pages each, and there's 25 maybe 25 different projects, that's 250 pages for me to write notes about for you guys. So when you're going to submit, I really want you to submit a rough draft. But if you submit it at the last minute, I won't have time to look at it. Do you see that? So one thing is the very last moment that you're allowed to submit it is 8 a.m. on Thursday before it's due. But then it might be Saturday before I get back to you because you're last. And the way I'm going to do it is it's first submitted, first read in terms of drafts. I only read one draft per group and I give you lots of advice, feedback. But I strongly recommend you submitting a draft and don't wait till the last minute. Even that Thursday, I recommend like Monday because it's a long time from now. If we go back to the syllabus, you will see the project is due on May 11th. Okay. That's almost a month from now. So you have a long time. So don't wait till the last 2 days and you already have all the information you need in terms of statistics. So there's nothing good about waiting till the end. Does that make sense? You don't have to finish it all this week, but I recommend, maybe having your draft done 5 days, 6 days before it's due. Does that make sense? Kind of like May 5th or so. And then you email me the draft, and then I'll give you feedback. But it's not going to be in 5 minutes because reading 10 pages and giving feedback takes time. Okay. I don't just like pretend I read it and say, nothing needed. I read every little line. And then I usually do like maybe the top 10 things that you need to change. Any questions at all on the project? Okay, and then it's due that May 11th, but I recommend trying to turn it in May 10th because that way, if something goes wrong, your technology, whatever, then that gives you the extra day. So I don't recommend waiting till the very end, and late submissions aren't accepted, so you need to submit on time. But the hope is you don't even wait till May 11th because you have a long time between now and then. So if it was May 10th, that's not really much different. Do you see? Okay, so I'm just looking at the time, and this is around when I like to end. So hopefully this helped out. What I'm going to do is I'm going to stop the recording and stop the share, but I can still answer any questions you have. And again, I have my student hours that I can always answer them too. And so does the tutor. And then let's see, just checking. I didn't see him. No, it's not here. Okay, so I'm going to stop the recording.